Hi, I'm Robert McDougall from Cesar Australia, and I'm here today to talk about our newly released Grains Beneficials Chemical Toxicity Guide. We're hoping that this guide will allow growers to make more informed choices about the chemicals they use to control pests in their cropping systems, and that by doing so, they'll be able to improve the sustainability of their systems, both from an environmental level by preserving biodiversity, and hopefully from an economic level as well by preserving organisms that can carry out some of the work of pest control in their systems and hopefully ultimately reduce costs in terms of pest control actions that the farmers need to undertake. This guide is freely available from our website on the address that you can see on the screen there, and we encourage anyone who's interested to download it. So what do we mean by beneficial organisms? That can be a very broad term, but in this context, we're talking specifically about organisms that can play a role in pest control. So we're meaning predators and parasitoids of potential pests. So this can mean things like ladybirds, things like parasitic wasps, any type of organism that controls organisms that could be a pest. And many, just by going about their daily lives, the many species of beneficial insects out there mean that many organisms that could become pests never become so. And it's been estimated that these natural enemies provide tens of billions of dollars of value in pest control services to global agriculture annually. So this is what our table looks like. It looks fairly simple, and it is simple by design. We want it to be easy to download and refer to, but it's underpinned by several years of research, extensive laboratory trials, as well as extensive consultation with the literature and experts in the field. The way it's set out is that on the left we have a list of chemical active ingredients commonly used to control pests within the Australian grains industry. And across the top, we have a list of groups of important beneficial organisms. And at the cells where they coincide, we've got a rating given for the toxicity of that chemical to that particular organism. And this toxicity is measured by proportion mortality and is given on a scale that's commonly used for laboratory trials by the International Organization for Biological Control. So in the most basic case, how to use this table, the table is ordered from least to most toxic from top to bottom. And so in the most basic case, a farmer can simply refer to this table and pick whatever chemical treats their pest, the relevant pests in their systems that has the least impact on other organisms. So working from the top down, for example, if you're looking to control aphids, you could go down, you'd find flunicimide is right near the top of the table. It's an aphid specific chemical. And you can see looking across the table, it has very little impact on the majority of organisms that would apply to. So that would be a good go-to choice for aphid control. In situations where farmers have the time and resources to carry out monitoring or have good local knowledge of the natural enemies in their system, there's some potentially more nuanced ways this table can be used. For example, say a farmer is aware that they have a good stable population of ladybirds in and around their crops, and these ladybirds are probably doing a good job of controlling aphids and scale insects and the like, but they're starting to worry about having problems with something like diamondback moth. They could just go down the list, find an active ingredient that they know is effective against diamondback moth and one that has minimal impact on ladybirds. So in this circumstance, something like MMX and benzoate might be a good choice. Finally, we're hoping that farmers will be able to use this table to help develop integrated pest management programs. Integrated pest management is just the idea of using multiple means of pest control instead of just a single means that can result in your pests developing resistance. And all farmers are probably doing this anyway, even if they don't think of it in terms of this diagram we've got on screen. They'd all be using cultural means, so things like resistant cultivars of crops and the like. They'd all be using physical means, so this could include basic hygiene, for example, stopping potentially infested plant material from entering a farm and the like. It only gets a bit more confusing when we get to the top of the table, to the top of the pyramid here, when we look at chemical and biological control, because as we've noted, chemical control agents can, in many circumstances, harm biological control agents. So this table, we hope, will take away some of that confusion as well. So Let's take another example. A farmer has some issues with caterpillars, but wants to use biological control on these, and this can be done these days. You can purchase caterpillar parasitoids from a couple of different commercial outlets in Australia. You can release them in your field, and hopefully they'll establish a population that might provide ongoing control of caterpillars. Well, that's great, but what if that farmer also has a problem with something like mites? Well, then the solution would be to look at this table, find something that controls mites, but that is relatively safe for your biological control agent. So in this case, something like ivermectin might work. And so hopefully this table can show farmers how to use both biological and chemical control means together in the development of integrated pest management programs. Our overall goals of this is to improve the sustainability of farms, both from an environmental and economic level. So we'd encourage everyone to please download it and share it widely. That's the address where you can get it from at the top of the screen. I'd like to thank our funding partners, the University of Melbourne and the Grains Research Development Corporation. My email address is at the top of the screen. I'm happy to take questions. And thank you very much for taking the time to listen.